We have a triangle whose sides are 13, 14, and 15 units. Now draw a circle in such a way that all the sides of the triangle are tangent to this circle, meaning each side touches the circle at exactly 1 point. Our goal is to find the area of this blue circle. You can pause the video and take a moment to think about it, and when you are ready, you can come back to verify your answer. Alright, let us solve it together. But before we begin, first let's mark the center of this circle, and draw the radius from the center to a point of tangency like this. Now can you tell me, what is the angle between this radius and this tangent line? Yes, you are right. It will be a right angle. Why? Because we know that whenever the radius is drawn from the center of circle to a tangent, it is always perpendicular to the tangent. Now let's do the same for these other two tangency points. Those radii are also perpendicular to the sides like this. Let us call all these radius as r. Next, connect the center of the circle to the 3 vertices of the triangle like this. This divides the original triangle into 3 smaller right triangles, each with height r and with bases equal to the triangle sides. Now can you tell me, what will be the area of this triangle? It will be equal to base multiplied height over 2, right? So the area of this small triangle with base 13 will be equal to 13 times r over 2. Similarly, the area of this small triangle with base 14 will be equal to 14 times r over 2, and the area of this small triangle with base 15 will be equal to 15 times r over 2, correct? You might be wondering why we are doing this. Because area of this original triangle will be equal to the sum of all of these 3 triangles, right? So adding all of them gives us this, and this, which simplifies to 42r over 2, or 21r. Now look, we can also compute the area of this original triangle directly using Heron's formula. Here this S is the semi-perimeter, and A, B, and C are the sides of the triangle. In our case, A equal to 13, B equal to 14, and C equal to 15. So the semi-perimeter S will be equal to 13 plus 14 plus 15 over 2, which equals 21. And substituting this into Heron's formula, we get the area of this triangle as 84 square units. Great, now we only have to equate both of them. 21r equals 84. And solving this gives us r equals 84 divided by 21, or 4 units, and that's it. Finally, finding the area of this circle will be super easy. It will be equal to pi times r squared, and substituting r equal to 4, area becomes pi times 16. That is 16 pi square units. And that's our final answer. Pretty neat, right? But wait, before you go, I have one bonus challenge for you. Can you find the area of this circle in terms of a variable x, y, and z instead of a specific number? Think it through and share your answer in the comments below. Let us see who can figure it out. If you enjoyed this explanation and learned something new, do not forget to like the video, share it with your friends, and subscribe for more fun, brain-teasing math questions. Thanks for watching, and I will see you in the next video.